When installing an emergency generator with an automatic transfer switch, several grounding considerations are critical for safety and proper operation. Firstly, a ground rod should be installed at the emergency generator and connected to the generator's grounding system. This provides a local ground reference for the generator itself. Secondly, a grounding conductor should be run from the emergency generator's grounding system to the transfer switch's grounding terminal. This conductor provides a path for fault current to flow back to the generator, allowing overcurrent protection devices to operate properly. The grounding conductor from the emergency generator to the transfer switch is typically sized at 8 American wire gauge or larger, but should be verified through proper calculations. It's important to note that the grounding systems at the service disconnect and the emergency generator should not be directly connected. The two systems should remain isolated from each other to prevent circulating currents in ground loops. Regarding the 20-amp single-phase breaker feeding the block heater and battery charger on the emergency generator system, this circuit should have a grounded conductor running from the service disconnect to the block heater and battery charger. The grounded conductor should be sized according to the breaker amperage and the equipment being supplied, typically 12 American wire gauge copper for a 20-amp circuit, but this must be verified. Several additional considerations are crucial for a safe and compliant installation. Make sure that all grounding conductors are properly sized and installed according to the applicable electrical codes, such as the National Electrical Code, also known as the NEC. Proper sizing is essential to ensure that the grounding conductors can safely carry fault current. Verify that the transfer switch is properly rated for the generator output and is installed in accordance with the manufacturer's instructions. The transfer switch must be able to handle the full load of the generator without overheating or failing. Test the entire system, including the transfer switch, to ensure proper operation. This testing should include verifying that the transfer switch automatically transfers the load to the generator when utility power is lost and that the generator starts and runs properly. Now let's elaborate further on each of these points to provide a more detailed understanding. Grounding the emergency generator is crucial for several reasons. It provides a low impedance path for fault current to flow back to the generator, which helps to ensure that overcurrent protection devices, such as circuit breakers or fuses, will operate quickly and clear the fault. This helps to prevent electrical shock hazards and equipment damage. The ground rod should be installed as close as practical to the generator, and it should be driven into the earth until it is below the frost line. The grounding conductor should be connected to the generator's grounding terminal, which is typically located on the generator's frame. The size of the grounding conductor should be determined based on the size of the generator's output conductors, as specified in the National Electrical Code Table 250.122. Connecting a grounding conductor from the emergency generator to the transfer switch is equally important. This conductor provides a continuous ground path between the generator and the transfer switch, which helps to ensure that the transfer switch is properly grounded. The grounding conductor should be connected to the generator's grounding terminal and to the transfer switch's grounding terminal. The size of the grounding conductor should be determined based on the size of the generator's output conductors, as specified in the National Electrical Code Table 250.122. It is critical that the grounding systems at the service disconnect and the emergency generator remain isolated from each other. Connecting these two systems together can create a ground loop, which can cause circulating currents to flow through the grounding conductors. These circulating currents can cause nuisance tripping of circuit breakers, equipment damage, and even electrical shock hazards. The National Electrical Code Section 250.30 A5 specifies the requirements for grounding separately derived systems, such as emergency generators. This section requires that the grounding electrode conductor for the separately derived system be connected to a grounding electrode that is separate from the grounding electrode for the service. Regarding the 20-amp single-phase breaker feeding the block heater and battery charger, it is essential that the circuit has a grounded conductor, also known as a neutral conductor. The grounded conductor provides a return path for current to flow back to the source, which is the service disconnect in this case. The grounded conductor should be connected to the neutral terminal at the service disconnect and to the neutral terminal at the block heater and battery charger. The size of the grounded conductor should be determined based on the size of the ungrounded conductors, as specified in the National Electrical Code Table 250.122. In addition to these specific grounding requirements, there are several other considerations that are important for a safer and compliant emergency generator installation. All grounding conductors should be properly sized and installed according to the applicable electrical codes. The National Electrical Code provides detailed requirements for the sizing and installation of grounding conductors. It is essential to follow these requirements carefully to ensure that the grounding system is effective. The transfer switch must be properly rated for the generator output and installed in accordance with the manufacturer's instructions. The transfer switch is a critical component of the emergency generator system, and it must be able to handle the full load of the generator without overheating or failing. The manufacturer's instructions will provide specific guidance on how to install the transfer switch properly. The entire system, including the transfer switch, should be tested to ensure proper operation. This testing should include verifying that the transfer switch automatically transfers the load to the generator when utility power is lost and that the generator starts and runs properly. Regular testing is essential to ensure that the emergency generator system will function properly when needed. Now let's delve a bit deeper into the National Electrical Code requirements for grounding emergency generators. The National Electrical Code Section 700 covers emergency systems, and it provides specific requirements for the grounding of emergency generators. Section 700.10 D requires that emergency systems be designed and installed so that they will function properly when the normal power supply is interrupted. This includes ensuring that the grounding system is adequate to handle fault currents and prevent electrical shock hazards. Section 250 provides the general requirements for grounding and bonding, and it applies to emergency generators as well. Section 250.30 A5, as mentioned earlier, requires that the grounding electrode conductor for a separately derived system, such as an emergency generator, be connected to a grounding electrode that is separate from the grounding electrode for the service. This is to prevent ground loops and circulating currents. The grounding electrode system for the emergency generator should consist of one or more of the following electrodes: a metal underground water pipe, a metal frame of the building or structure, a concrete encased electrode, or a ground ring. If none of these electrodes are available, then a ground rod or ground plate can be used. The grounding electrode conductor should be sized according to the National Electrical Code Table 250.66, based on the size of the largest ungrounded conductor of the generator output. The grounding conductor that runs from the generator to the transfer switch is often referred to as the equipment grounding conductor, or EG. The equipment grounding conductor provides a low impedance path for fault current to flow back to the source, which helps to ensure that overcurrent protection devices will operate quickly and clear the fault. The equipment grounding conductor should be sized according to the National Electrical Code Table 250.122, based on the size of the overcurrent protection device protecting the circuit. In addition to the equipment grounding conductor, there may also be a need for a bonding jumper to connect the generator frame to the grounding electrode system. A bonding jumper is a conductor that connects two or more metallic parts together to ensure electrical continuity. The bonding jumper should be sized according to the National Electrical Code Table 250.102, based on the size of the largest ungrounded conductor of the generator output. When installing the grounding conductors, it is important to follow some best practices to ensure a reliable and effective grounding system. All grounding conductors should be installed in a neat and workmanlike manner. Avoid sharp bends or kinks in the conductors, as these can increase the impedance of the grounding path. All connections should be made with approved connectors and should be properly tightened. Avoid using dissimilar metals for connections, as this can lead to corrosion and increased resistance. Protect the grounding conductors from physical damage. If the conductors are exposed to physical damage, they should be installed in conduit or other protective raceway. Inspect the grounding system regularly to ensure that it is in good condition. Check for loose connections, corrosion, or damage to the conductors. Repair any problems promptly to maintain the integrity of the grounding system. Finally, it is always a good idea to consult with a qualified electrician if you are unsure about any aspect of the emergency generator installation. A qualified electrician will have the knowledge and experience to ensure that the installation is safe, compliant, and reliable. Let's move on to discuss some common mistakes to avoid when grounding emergency generators. One common mistake is to use undersized grounding conductors. The National Electrical Code provides specific requirements for the sizing of grounding conductors, and it is important to follow these requirements carefully. Using undersized conductors can compromise the effectiveness of the grounding system and increase the risk of electrical shock hazards. Another common mistake is to connect the grounding systems at the service disconnect and the emergency generator together. As mentioned earlier, this can create a ground loop and cause circulating currents. It is important to keep these two grounding systems separate. Another mistake is to fail to properly bond the generator frame to the grounding electrode system. The generator frame should be bonded to the grounding electrode system to ensure that it is at the same potential as the earth. This helps to prevent electrical shock hazards. Another mistake is to use improper connectors or connections. All connections should be made with approved connectors and should be properly tightened. Avoid using dissimilar metals for connections, as this can lead to corrosion and increased resistance. Another mistake is to neglect to inspect the grounding system regularly. The grounding system should be inspected regularly to ensure that it is in good condition. Check for loose connections, corrosion, or damage to the conductors. Repair any problems promptly to maintain the integrity of the grounding system. By avoiding these common mistakes, you can help to ensure that your emergency generator installation is safe, compliant, and reliable. Finally, let's consider the impact of different types of grounding systems on emergency generator installations. There are several different types of grounding systems that can be used, including grounded systems, ungrounded systems, and impedance grounded systems. Each type of grounding system has its own advantages and disadvantages, and the best type of grounding system for a particular application will depend on the specific requirements of the application. Grounded systems are the most common type of grounding system. In a grounded system, one of the conductors is intentionally connected to ground. This provides a low impedance path for fault current to flow back to the source, which helps to ensure that overcurrent protection devices will operate quickly and clear the fault. Grounded systems are generally considered to be safer than ungrounded systems, as they reduce the risk of electrical shock hazards. Ungrounded systems do not have any conductors intentionally connected to ground. In an ungrounded system, a fault current will not flow until a second fault occurs on a different phase. Ungrounded systems are sometimes used in applications where it is critical to maintain power continuity, as a single fault will not cause the system to shut down. However, ungrounded systems are generally considered to be less safe than grounded systems, as they increase the risk of electrical shock hazards. Impedance grounded systems use an impedance such as a resistor or reactor to limit the amount of fault current that can flow. Impedance grounded systems are often used in applications where it is desired to limit the amount of fault current to protect equipment from damage. Impedance grounded systems can be either high resistance grounded or low resistance grounded, depending on the value of the impedance. The choice of grounding system for an emergency generator installation will depend on a number of factors, including the size of the generator, the type of load being served, and the applicable electrical codes. It is important to carefully consider all of these factors before selecting a grounding system. To reiterate, proper grounding is essential for the safe and reliable operation of an emergency generator system. By following the guidelines and best practices outlined here, you can help to ensure that your emergency generator installation is safe, compliant, and effective. Always consult with a qualified electrician if you have any questions or concerns about the installation. Remember to always prioritize safety and follow all applicable electrical codes and regulations. Safe electrical practices are paramount when working with emergency generators and transfer switches. The information provided here is intended as a guide and should not be considered a substitute for professional electrical expertise. Grounding requirements can vary based on local codes and specific equipment configurations, so it's crucial to verify all details with qualified professionals. By adhering to these principles, you contribute to a safer environment for yourself and others working with or around emergency power systems. Always disconnect power before working on any electrical equipment. Use appropriate personal protective equipment such as gloves and eye protection. Be aware of your surroundings and potential hazards. If you are not comfortable working with electricity, do not attempt to do so. Call a qualified electrician. Electricity can be dangerous if not handled properly. By taking the necessary precautions, you can help to prevent accidents and injuries. Remember that emergency generators and transfer switches are complex systems that require careful planning and installation. Proper grounding is just one aspect of a safe and reliable installation. By following all applicable codes and regulations, and by consulting with qualified professionals, you can ensure that your emergency power system will function properly when needed. The importance of regular maintenance and testing of emergency generator systems cannot be overstated. Periodic inspections and tests can identify potential problems before they lead to system failures. This includes checking the condition of grounding conductors, connections, and electrodes, as well as testing the transfer switch operation and generator performance. A well-maintained emergency generator system provides peace of mind knowing that it will be ready to provide power when needed most. Finally, it's important to stay informed about the latest developments in electrical codes and standards related to emergency generators. Codes and standards are constantly evolving to reflect new technologies and best practices. By staying up to date, you can ensure that your emergency generator installation meets the latest requirements and provides the highest level of safety and reliability.